Hello, hello, hello. Can you guys hear us? Let me see if now we should be opening it up. Thank everybody. Welcome once again to the Professional Cloud Developer Certification Study Group. Thank you so much, everybody, for joining. I was just like, if you should have seen me on the other side of the screen, like beaming with so many people joining us from all over the world. Thank you so much, everybody, for making this community the way it is and bringing yourself, bringing your energy, and bringing your community, of course, to this session. So thank you once again. This is, again, the Professional Cloud Developer Certification Study Group. This is session number 1. We have a jam-packed session for all of you, so please stay tuned. Kevin is going to be dropping a couple of links. So Hadid from Mars, yeah, you topped it. Yeah. How's everybody else doing? I hope again, I love that we get always our usual suspects: Hadid, Linda, Kevin, Paul, and some of you out there that always follow us and always are part of this family, this community that every year we reconvene to study, to be better, to learn more about the cloud, to get on top of the industry, to learn those great skills. So we're gonna start recording right about now. With your permission, we're gonna start recording, and then we're gonna go right ahead with the session. I just wanted to go with a couple of hellos as always. Remember, at the end of every session, we take a picture. So I hope that some of you open up your cameras and give us your best smile so that we as a community, take a group picture every official session. So hope that you can stay all the way at the end. Kevin is going to be dropping some links. Tonight, we're going to have raffles. So again, as a token of our appreciation for those of you joining, again, unfortunately, the raffle is only for US and Canada only, but if you have somebody in US or Canada that can ship you the item, we can do that, because unfortunately the Google merchandise store only ships to US and Canada. So if you have a friend in maybe one of these countries, you have an address that we can send it to you, we'll do that. Please put your name in the raffle. We're going to be raffling some items later, but let's start right away with the session. Okay, we already started recording, which is great. That's fine. So let's just do it more officially. Thank you. Yes. So again, thank you one more time to the Professional Cloud Developer Certification Study Group, Session 1. My name is Roman Jacques. Here with me, Kevin Kwan, my co-organizer at GDG Lawrence. And of course, we always have to thank all of the communities co-hosting this amazing session. We have all over the place, not only you coming from all over the world, but we have folks from GDG Hudson, Ocala, San Jose, Fremont, Annapolis, Tampa Bay, Austin, Baltimore, Capital Region, Linda. Thank you so much. Cloud Fremont, from all over the place. Thank you so much for supporting this amazing community in these sessions that bring us not only together, but our passion for cloud. So let's get certified, everyone. Let's start. So of course, we're going to be focusing on, like we mentioned, we're going to be professional cloud developer. If you see that badge, look at that badge, because you're going to get it really soon. So again, this professional cloud developer is it's a professional that builds and maintains highly available applications using Google recommended practices and tools. For these 12 sessions that we put together, we've prepared all the content and the path that will put you in the right spot, in the right track, so that you can get certified at the end of these 12 sessions. So please stay tuned with us. Keep hitting it, keep pushing forward and completing those challenges. You can see the batch tracker, how everybody, there's already a lot of people on the great track. And Manuel, Prakash, Samina, you guys are rocking it. So please keep it up. I'm always behind, but it's because I got to put so many things together, but I'm always there. I see TC Lee, Marcio, Wing Wong, a lot of people. Kevin, you got to step it up, man. So yes, I know, there's so much content going, there's so much content to cover. but I'm telling you, it's worth it. This a series of sessions and this certification in particular is very rich. It's very hands-on. I loved it. I couldn't let it go, and that's why I completed like all my badges. But I'm gonna continue completing all the other ones. So the same thing for all of you. So again, professional cloud developer is what we're focused on this session or in this series, and especially this session, we're gonna be covering some of those aspects. So again, remember, we already did the pre-work. We already went over what the professional cloud developer exam entailed. We also did some reviews. I gave you a little bit of homework for you to complete, like the initial lab. You should be in where it says week 1, that is highlighted. You should be at that spot. Week 1, which covers the Google Cloud fundamentals and core infrastructure, which is what we're going to be covering tonight. So tonight we're going to be covering the Google Cloud fundamentals, core infrastructure. If you didn't complete it, that's okay. It's going to be a preview for you. But if you did it, if you already completed this, congrats to you. This is going to be a review. So we're going to be reviewing the Google Cloud fundamentals, the core infrastructure module that puts us again one step forward towards our end goal, which is getting the professional cloud developer certification. So yes, Kevin, please just drop the link one more time as a token of our appreciation. We're going to pick 2 winners. Either scan the QR code on the screen, or you can copy that short URL on the screen, and you're going to be able to pick one of these 5 items, and we're going to ship them to you. Again, only for US and Canada residents. But if you have somebody in those countries that we can ship your swag to them, then you can participate on this raffle. So you can pick one. Go ahead, Kevin.
I pinned the links at the chat.
Oh, perfect. Okay, even better. So the link is pinned on the chat. Please make sure to join the raffle. Put your name in there. We're going to pick your name at the end of the session. Thank you, Kevin. So you can pick like a notebook, a t-shirt, a mug, a hat, socks. I love the socks. So make sure to put your name in there, because we're going to pick 2 lucky winners as a token of our appreciation, so that you can get one of these items. Okay. Thank you so much. Let's continue, because we have a lot to cover. So again, Cloud Skills Boost, we talked about that. A few of you may not have already gotten the credits, but make sure to sign up for all the sessions so that you could get not only the ability to complete the hands-on labs, but also check out all the on-demand content, complete the quests and whatnot. Make sure to get on this URL, tinyurl.com/PCD-path, and you can see the whole PCD path for Cloud Skills Boost for the professional cloud developer. We mentioned how to get the Cloud Skills Boost. Make sure to RSVP to all the sessions. We don't need to repeat that again. And of course, remember, if your name is not on the badge tracker right now, you still have time. You want to see your name in there. You want us to keep tabs on you to see how you're completing your challenges and all the badges. Sign up for the RTC tracker, for the Road to Certification badge tracker, following that that URL. And of course, you want to access the badge tracker. You just go to rtc-gdglawrence.web.app, and you can see the same badge tracker that we have right there. Kevin already dropped the links in the chat. So you still have time. If you don't see your name in there, that's okay. We'll put you in it, and then we can keep track of you. Okay. Perfect. Make sure to join our Slack. That's where we answer the questions. I saw a lot of you in the past 2 weeks interacting and chatting, sending me messages. We were solving problems. So thank you so much for joining the Slack and interacting as a community. I was even doing like a more hands-off approach, and you guys were answering questions among each other. I love that. Please continue the conversation. Please continue the chatter on the Slack channel. Awesome. Thank you so much. Let's start right away. We're going to talk about remember, we're going to cover today, we're going to be covering the Google Cloud fundamentals, core infrastructure. We're going to cover what it entailed, what that module covered. We're going to go over that tonight. So pay attention. I'm just going to go over, it's pretty much going to be like a review of what is in there. If you haven't watched it, it's going to be like a spoiler for you, but that's great, because at least it's going to be a preview of what you're going to be seeing. And for those of you who complete it, it's going to be a review. That's it. And if you have any questions, Kevin is going to be taking some of those questions out there. So let's start right away. So what we're going to talk about initially is about cloud computing. So what do we talk? Where do we say? What are we referring to when we talk about like cloud computing? So cloud computing, again, is a way of using information technology or IT that has these 5 equally important traits. Again, consumers get the computing resources that are on demand and self-service. Actually, I need to go to the next slide. That way you could see those 5 traits. So cloud computing entails these 5 traits. 1, customers get computing resources that are on demand and self-service. What does this mean? You don't have to call anybody at 3 a.m. and say, hey, I need you to make me a bucket. I need you to create me a cloud function. No, you go to the Google Cloud, and in this cloud infrastructure, you can get those resources on demand, any self-service, like you provision those yourself. Number 2, customers get access to those resources over the internet from anywhere. You don't have to drive anywhere. You don't have to go to a data center. No, even using this, the Google Cloud Console, which is a web-based interface, you can access all of those resources over the internet. As long as you have a solid internet connection, you can access those resources. Number 3, the provider of those resources allocates them to users out of that pool. That doesn't mean that there's somebody else on the other side, like, oh, can you make me a compute instance VM? And then the person just, oh, okay, let me install a rack and then put like a server and then install it on the rack for Kevin, for example. No, that's not like that. It's actually, you're put into a pool of resources. Everything is virtualized. Everything is not like physical hardware where they allocate for you. It's a pool of resources that then they can put you on. So, for example, let's say if you request disk space, they actually allocate a chunk of like a block disk for you out of a pool of resources. It's not like they're going to install it for you, or you have to like drive somewhere and check, oh, let me see, where's my server? You don't see that. It's all, again, you get allocated into a pool. Number 4, resources are elastic, which means they are flexible, so customers can be. What does this mean? Let's say if you're getting a lot of traffic, let's say you just created a website and then you are getting a lot of traffic. Instead of you saying, oh, let me call somebody so that they can then add another server, and then let's say, for example, like if you want to expand it, you want to scale vertically or horizontally. If you want to scale horizontally, can you install another server for me? Or if you want to scale vertically, can you add more memory or disks for me? No, you could do that yourself. Or that's how it's flexible. So some of these are actually auto scale, that they actually increase or reduce, and they scale automatically based on the traffic, based on the usage, and all of that happens very in a flexible fashion. And last but not least, number 5, customers pay only for what they use or reserve as they go, instead of you either paying up front or paying for things being idle, or you have to send a money order or a check or put your credit card. Well, you still need to put your credit card, but at least you pay for what you use. In the case, for example, like of cloud functions, only when the cloud functions execute is when you pay. You don't pay when just because a function is hosted on the Google Cloud. The same thing for, let's say, compute instances, a given another instance, but let's say if you have things running on the compute engine instance on a VM, for that machine being running is when they charge you. They charge sometimes by the millisecond, by the second, by the time that you have stuff running. When you make a request, when you get a response, stuff like that, you get you pay for what you use, not like again, like old models before. Again, they're talking about how the move to virtualized data centers introduce customers to 2 new types of offerings. Where they mentioned that a lot in this videos. They talk about IaaS, or infrastructure as a service, commonly referred to IaaS, and platform as a service, or PaaS. Right? IaaS offerings provide raw compute, storage, and network capabilities organized virtually into resources that are similar to like a physical data center, like I was mentioning. For example, compute engine virtual machines are an example of a Google Cloud IaaS service, or infrastructure as a service. They provide the infrastructure for you. Then platform as a service, which is PaaS. In contrast, they bind code to libraries. They provide access to the infrastructure application needs. And all you need to do is just pack your code and send it over. One of the offerings, one of the platform as a service offerings is, I believe it's App Engine, but it's getting deprecated for other more modern solutions. Yeah, so here they're talking about, for example, like how you deal with managed resources and managed services. The move to virtualized infrastructure now has moved us away from having, for example, like physical infrastructure, like physical servers and like a physical data center on your company. Instead, you get like managed resources and managed services that Google takes care of those things for you. You only have to manage, for example, like, make sure that your users are there, your data is available, you put your information in there, but Google takes care of, the electricity, the, turning on the lights, that make sure that it's secure, stuff like that. So it's managed. That's why they call it managed service and managed resources. Serverless is one of my favorite ones. So you're going to hear a lot about serverless when they talk about the core infrastructure of the Google Cloud. Serverless is yet another step in the evolution of cloud computing. Why? Because it allows developers to concentrate on their code rather than on server configuration by eliminating the need for any infrastructure management. In the case of serverless, it's not like the server doesn't exist. There is a server, but it's completely transparent to you. You don't have to provision infrastructure. You don't even need to care about that. All you need to care about your users, providing a great service, building amazing applications, and Google takes care of the rest. Or in this case, cloud infrastructure, all of that takes care of that for you. But there's a service, but they call it serverless because there's no, again, server configuration, server infrastructure, none of that. Again, in the two of the serverless technologies that are my favorite and are going to be touched a lot throughout the series are, again, Cloud Functions and Cloud Run. So these serverless technologies offered by Google, again, Cloud Functions, which manages event-driven code as a pay-as-you-go service. And then you have Cloud Run, which allows customers to deploy their containerized microservices, based applications in a fully managed environment. So Cloud Functions are those, very centric, very portions like functions, like code, a very, very specific code that you want to execute, like a function, and you don't have to provision any infrastructure in order to make them run. And Cloud Run is like the concept of serverless containers. So it's pretty good. It's a very, modern offering, and you're going to see that a lot in even building applications for mobile, web, server applications. They talk a lot about, again, software as a service, how SaaS provides the entire application stack, and the Google Cloud is the best infrastructure for you to build like your SaaS business. So SaaS provides the entire application stack, delivering an entire cloud-based application that customers can access and use. Remember, as long as you have a solid internet connection, you can access cloud services. In this case, any SaaS-based software, you can access it, software as a service. These applications are not installed on any local computer. If you have a browser, you're able to access that. So they run in the cloud as a service, and they're consumed directly over the internet by end users. You don't have to install anything. Wherever you are, you can access this service. So that's why they call it software as a service. You don't have to install anything. All you need is like a browser, and then you can access it over the internet. They talk about a lot, even on the exam, they talk a lot about the global network, how Google Cloud runs on Google's own global network. It's the largest network of its kind, and Google has invested billions of dollars over years to build it. You see how Google Cloud's infrastructure is based in 5 major geographic locations: North America, South America, Europe, Africa, Asia, Middle East, and Australia. And having multiple service locations is important because choosing where to locate your application affects the qualities like availability, durability, and latency. What they emphasize with this is that depending on where, let's say, your core of your users are, this is where you deploy your services in these specific regions, in these locations all around the world. And Google has like their own, all these locations, where high demand content is cached for quick access. That is a benefit for your users. So that's something that you need to make sure, to keep in mind. They talk a lot about how the Google's infrastructure, how the Google's global network is divided into locations, regions, and zones. Regions represent independent geographical areas that are composed of zones. So you have like a region, right? Let's say London. London is a region. Europe West 2. That is a region that currently comprises 3 different zones. So you have a region, and then a region is that geographical location, and then inside you have zones. So you have the location, which is London, the region, Europe West, and then you have zones. Zones is the area where the Google Cloud resources are deployed. This is what equates mostly to a data center. But for example, if you launch a virtual machine using Compute Engine, it will run in the zone that you specify to ensure resource redundancy, right? You have a zone can even be split into multiple data centers, for example. So it's a little bit more granular when you go down to the data center. But people usually don't refer to that like to the actual physical data center. But at least you can break it down into locations, regions, and then zones. And then honing in more on the zone, because now we want to be more local. So a zone is at the area where the Google Cloud resources are deployed. For example, if you launch a virtual machine, like I mentioned, you can run the resources, within that zone. But you could also have resources that go across regions as well. So those are the things that you need to keep in mind. That distribution of your resources across geographical locations, depending on whether you have a virtual, regions, locations, regions, and zones. And they explain here, for example, like how cloud storage. Let's say you could be in a region, and then you have like multiple zones underneath it. For example, within the Europe region, you have the London, you have Belgium, and then you can break it down more like that. They talk about, again, remember we talked about the billing, like how they charge you, whether, when you pay as you go, this is how they charge you. So Google has was the first major cloud provider to deliver per second billing. Instead of like, okay, we're going to charge you, if you use it for an hour, we're going to charge you for the whole day. Or if you just spend 1 minute, we're going to charge you for the whole hour. That sucks. So Google was the first major provider to deliver per second billing for its infrastructure as a service computer offering, which is Compute Engine. Compute Engine, whenever you hear Compute Engine, think of like a virtual machine in the Google Cloud. In addition, per second billing is now offered for users of Google Kubernetes Engine, Dataproc, which is the equivalent of like big data system Hadoop, but operating as a service, and App Engine Flexible. App Engine is going to be deprecated a little bit, but remember, App Engine is what I talked about as like the platform as a service. Now they're favoring more the serverless containers like Cloud Run and Cloud Functions, like those specific event-driven, very unique, like solely single-purpose functions. So they're kind of like favoring more of those type of offerings. We talked about, for example, like how then you can, some people say, yeah, but I don't like the Google Cloud because sometimes it racks up a huge bill. Before you even deploy your resources and before you even try the Google Cloud, you can even check how much, roughly as an estimate, you can get, you're going to be charged. Let's say I want to deploy a couple of cloud functions. I want to have a cloud SQL database. I want to have a couple of cloud run containers running. How much is Google going to charge me? I don't want to deploy all of that and then get a huge bill. You can use the Google Cloud calculator, and then you can just change knobs and put things in there, and then it can give you a rough estimate of how much you're going to be charged. Let's say, per second, per hour, whatever, depending on the resources that you allocate. The Google pricing calculator is great because it gives you that capability so that before you even rack up a huge bill, you can check how much it's going to charge you. So the pricing calculator, there are questions in the exam about that. So now you're probably thinking, okay, so how do I make sure that I don't run up a big Google bill, but now I already created my services. Yeah, I checked it using the calculator, but now I'm ready to start doing that. But how do I prevent it? Well, there are a lot of tools that Google has that prevent you from racking up a huge bill and to be cautious about your costs. So you can define things called budgets. You can define budgets at the billing account level or at the project level. A budget can be like a fixed limit, or it can be tied to another metric, for example, a percentage of the previous month's spend. You want to be notified when costs approach your budget limit, so you create alerts. You can even create alerts that you can get like an email, a text message, like an SMS message, so that whenever, let's say, your budget is reaching like its limit. Let's say you have a budget limit of $20,000 and you have an alert at 90%. So you will receive a notification when your expenses reach $18,000. Alerts are generally set at 50%, 90%, and then 100%. It's not like the Google Cloud is going to let you, oh, wait, whoa, $20,000 on my bill. No. If you got a $20,000 bill, you didn't put budgets, you didn't set up alerts, and you didn't, you were not really conscious around putting like those guardrails around it. So make sure to do that whenever you want to do that. You can generate reports out of it so that you can view like your costs and all of that. Great. Yes. I know there's a couple of questions out there. Kevin is going to be addressing a couple of those while I go through, because there's a lot of content that I'm going over. We're talking about this gets in the exam. I can guarantee it 100%. This comes out on the exam. They talk about Google Cloud's resource hierarchy, how it contains 4 levels. All resources in the Google Cloud are organized in a hierarchy of 4 levels. Starting from the bottom up, you have resources, projects, folders, and organizations. That comes out on the test. No questions asked. At the first level, you have the resources. What are the resources? The resources are your virtual machines, your cloud storage buckets, tables in BigQuery, cloud functions, anything else in the Google Cloud. Those are your resources. That is the bottommost layer or node. Then resources are organized into projects. So inside of a project is where you add your resources. They sit at that second level. Then projects can be organized into folders or even subfolders. Let's say you want to create a folder for like HR, and then you have projects for HR so that they can manage, let's say, the employee information and all of that. You can have one called development, and then you create all the projects that the developers work. DevOps, you can create multiple folders, and then inside of the folders you have the projects. Inside of the projects, the resources. The folders sit at the third level. Now at the top level is the organization node, which encompasses all the projects, all the folders, all the resources. It's pretty much like the root level, right? The top level is the organization node. So for the exam, this comes out, remember, 4 levels: resource, project, folder, organization. They talk about, again, like, this is very important. You're going to get a lot about, for example, like permissions, how least privilege permissions. All of those things you're going to get. How the hierarchy, how the policies are managed and applied when you use the Google Cloud. Policies can be defined at the project level, at the folder level, and at the organization node levels. And some Google Cloud services allow policies to be applied to individual resources as well. But the policies are inherited downward. That comes out in the exam. Even you could go, you're welcome, actually, because I'm telling you exactly what's going to come out in the exam. So let's say if you apply a policy at a folder level, it will apply to all the projects within that folder. That's how it trickles down. So if you apply to a folder, it will do it to all the projects within that folder. So it's a hierarchical, it's kind of like a trickle down approach, right? They talk about like how the projects are the basis of enabling and using cloud services, managing APIs, enabling billing, adding and removing collaborators, and all of that. Each project is a separate entity under the organization node, and each resource belongs to exactly one project. Projects can have different owners. That's okay. Each Google Cloud project has 3 identifying attributes. This comes out on the exam. You need to know that a project has 3 unique things: project ID, project name, and a project number. And you need to know which one of those you can edit and which one is read-only and you cannot change it for the lifetime of the project. So you need to know those things. We talked about, for example, again, how the organization, that we already went over that. And this is what I wanted to mention. So the each Google Cloud project has three identifying attributes: project ID, project name, and a project number. The project ID is globally unique, assigned by Google, cannot be changed. Project ID cannot be changed. You're welcome. I just gave you an answer to one question from the exam. They're what they're referred as being immutable, so they cannot change. Project IDs are used in different contexts. Project names are user created. That is like the friendly name that you can change. So they don't have to be unique, but they can be changed at any time. So you can call a project my cool project, but a project ID cannot be changed. But my cool project, you can change it to, my super awesome project. Google Cloud also assigns each project a unique project number, like I mentioned, but the project ID is immutable. IAM. This is probably, Linda can, testify to this. This is probably like a quarter of the exam. IAM. IAM, again, with IAM, administrators can apply policies that define who can do what on which resources, right? So the who part of the IAM policy, identity access management, sorry. So identity and access management is IAM, is the who part of the IAM policy. For example, it could be a Google account, it could be a Google group, it could be a service account, a Google Cloud identity domain. The can do what is then defined by a role. A role is a set of permissions. Whenever we assign permissions, it's not recommended to be assigned to individual things. You actually collect the permissions within a role. Then you assign a role to a group, and then whenever you assign permissions, let's say to a role, and because the role was assigned to the group, it collectively applies to that group because the roles are applied to that. So that's how IAM works, identity and access management within the Google Cloud. So like I mentioned, an IAM role is a collection of permissions. For example, you want to manage a virtual machine instance in a project. You must be able to create, you must be able to delete, start, stop, and change virtual machines. Those are permissions. Create permission, create permission, delete permission, start permission, stop permission. So these permissions that are grouped in a role, and then that role I can call it, VM admin. So you see the VM admin is the role, and then that role has create, delete, start, stop permissions. Let's say now when a user group or a service account is given a role on a specific element of the resource hierarchy, then the resulting policy applies to both, not only the chosen element, but all the elements below in the hierarchy. Remember when I talked that trickle-down approach? If you apply it to a group or you apply it to a specific resource, it trickles down to all the elements below the hierarchy. They talked about these three kinds of roles. This comes out in the exam. You got to know it. So the three kinds of roles in IAM, identity and access management, are basic, predefined, and custom. You get probably like 10 questions on IAM around this specific thing. So you need to make sure to know what are these things, right? So there are three kinds of roles in IAM: basic, predefined, and custom. Basic are quite broad in scope. They say when you apply it to a Google Cloud project, they affect all the resources in that project. And basic roles, you probably have seen it. Basic roles are like owner, editor, viewer, and billing administrator. Those are like basic roles. Then you have predefined roles. Predefined roles are those ones that you create, like you customly create. You create some custom. The predefined ones are the ones that are kind of like a little bit lower than basic, but they're predefined. Like I mentioned, like VM manager, a cloud function viewer. You see, it's not editor, owner, or viewer, but it's a predefined one because it contains already some permissions underneath it. And then you get to the custom, which is the ones that you create yourself by compiling a set of permissions within a role. Let's say I want to say, I want to call this role, for example, this role, I want to call it GDG Lawrence admin. And then it has a bunch of permissions under it. But then I create that particular role myself. So you could do it like that. So they talked about a service account. Service accounts are crucial for almost everything in the Google Cloud. So you're going to get like 3 or 4 questions on service accounts. So let's say, what if you want to give a permission to a VM? What if you want to give a permission to a cloud function? What if you want to give a permission to a cloud pub sub? What if you want to give permission to BigQuery? What is it? Those are not people. You cannot create an email for a virtual machine. You cannot create an email and an account for a cloud function. Well, that's what service accounts are for. A service account. Let's say you have an application running in a virtual machine that needs to store data in cloud storage, but you don't want anyone on the internet to have access to that data, just to that particular virtual machine. So then you create a service account, which is kind of like an email, like an account that you create, but for that intangible, kind of like for a virtual machine, something inanimate, right? So service accounts are named with an email address, but instead of passwords, they use cryptographic keys to access those resources. So you create an email. Let's say you create a service account, and then you assign a role to this service account, and then the service account, then you assign it to a cloud function. Then this cloud function, if you add the permissions, for example, of like read database, that cloud function can read that database on your behalf without you having to manually, put like a connection string and hard coding those things. So service accounts are great for those things, to add permissions to those resources in the Google Cloud that are not a person, right? Otherwise, then you just create a regular account and assign it to somebody. So those things come out on the exam, no questions asked. They talk about also, this actually at least comes out like once in the exam. They talk about how many ways you can access the Google Cloud. You can access the Google Cloud through the console, through the SDK, through the Cloud Shell, through APIs, and through a mobile app. So you need to know the multiple ways in which you can access the Google Cloud. So you can access it through the console, Cloud SDK, Cloud Shell, the APIs, and the Google Cloud Console mobile app. So you need to know that. Cloud Shell, everybody has seen the Cloud Shell. Like, if you just go, actually, I can even pop it open right now. If you just go to, console.cloud.google.com, if you're right there and you just click here at the top right corner and you just pop it open, this is the Cloud Shell. That's it. And you can immediately, take a look at your resources in there. It's actually all web-based, and it's actually like a command line that you can interact with the Google Cloud right here. Of course, you could use the regular Google Cloud Console up here, and you can open up the menu and you have all the services and whatnot, but you can also open up the Cloud Shell, which is this. You get 5 gigabytes of home directory, like a home directory. It's actually a preemptive VM based on Ubuntu, and I think it's Debian Linux. And then they instantiate this virtual machine for you, and you're actually accessing this home directory. Like here, you can do a lot of things. You can do, you can instantiate servers. You can even program. You could go like, Python, and then I can start doing like, x equals 2, x times 2. So you can do like a bunch of things in here. Like the Google Cloud Shell is for that. So it's very interesting how you can use the Google Cloud Shell and the way that you can access the Cloud Shell. So it's pretty cool. This one, it was my headache all the time. Every time I took the test. VPCs, virtual private cloud. You need to know this for the exam. You need to know what a virtual private cloud is. So what is a virtual private cloud? A virtual private cloud, or VPC, is a secure individual private cloud computing model hosted within a public cloud, like Google Cloud. For example, you can have a private cloud within a public cloud. What does that mean? You can create your own private cloud within Google, within the Google Cloud, but it's private, is only accessible to you, and all of that. You can, you can run code, store data, host websites within that VPC. VPCs combine the scalability and convenience of the public cloud computing, but with the data isolation of private cloud computing. You can have subnets. You can, it's a subnet in the Google Cloud is like a segmented piece of a larger network. Subnets can span the zones that make up a region, and that's great because then you have a unique network layout so that you can organize your resources in a more comprehensive way that makes sense for you and your product. They talk about subnets, how the size of a subnet can be increased by expanding the range of IP addresses allocated to it. You have to learn about VPCs, about like CIDR ranges, like those IP addresses, how you can access those, how, for example, like from one region, from one zone, you can access the resources on another zone, how you create VPCs and all of that. They talk about how, for example, let's say if you have a network, like a VPC network named VPC1, for example, and you have two subnets under that VPC, and they are, for example, like in the Asia and US East region. But if the VPC has, let's say, some virtual machines attached to it, that means they're neighbors on the same subnet, even though they're in different zones. One is in the US, one is in Asia, but they can still talk to each other. Why? Because they're part of the same subnet within the same VPC. And that is how you can arrange your infrastructure within the VPCs and whatnot. You need to know VPCs to pass the exam. That is key. A compute engine. We talked about a lot of compute engine. Compute engine is virtual machines in the Google Cloud. That's it. You can create and run virtual machines. There are no upfront investments. And there are thousands of virtual CPUs that you can run on a system. Like I told you when I showed you here, like this, when I do exit. Here, for example, like this is a virtual machine. I'm actually currently accessing a virtual machine right now. This is a virtual machine that is dedicated for me, for my home directory, and I can do a bunch of things in here. I can run servers and whatnot. So those virtual machines is not something something that I can go and turn it off. You can definitely shut down virtual machines, but they're virtually created. You can spin them up. You can duplicate them. You can manage groups of virtual machines and whatnot. It's pretty cool. So again, let's continue. So again, like I mentioned, a bunch of CPU and memory power needed. Some of them, you need to specify the amount of storage that they require. You have a lot of granular control when you create those virtual machines in the Google Cloud through Compute Engine. They talk about, for example, if you use preemptible machines. I talked about preemptible machines or spot VMs. They're different from regular Compute Engine VMs. Why? Because the preemptible VMs can only run for up to 24 hours. Spot VMs don't have a maximum runtime. These are quick for like quick jobs that it doesn't matter whether the Google Cloud just shuts them down, so that's okay. They talk about a lot about how Compute Engine lets you choose the type of machine properties, the type of CPU, how much memory. You see, it's very flexible. It's very elastic, so to speak. Compute Engine has a feature called autoscaling, which is something really good because autoscaling is where VMs or those virtual machines can be added or subtracted from an application based on load metrics. You got a lot of traffic. Let's say, you get a bunch of traffic to your application. The Google Cloud can auto scale and can instantiate VMs on the fly and that's what they called load balancing. So Google's VPC supports several different kinds of load balancing, which we will explore later, but you need to know about load balancing in the Google Cloud using, for example, managed instance groups and whatnot. Again, I keep mentioning VPCs. You got to learn about that. VPC have routing tables. You need to know about that. Firewalls, security is paramount in the Google Cloud. You have, for example, like VPCs, they provide a global distributed firewall, which can be controlled to restrict access to instances through both incoming and outgoing traffic, or the way that they call it, ingress and egress. So you need to know those terms, ingress, egress. Again, how, for example, like globally distributed firewalls and all of that, how to add labels, how to add tags to virtual machines so that then you can apply firewall rules. So you need to know all of that. Remember that VPCs belong to Google Cloud projects. They're like any other resource. So you need to know that. Cloud load balancing, again, it comes out on the exam. You need to know that. What is the job of a cloud load balancer or the job of a load balancer in general? The job of a load balancer is to distribute user traffic across multiple instances of an application. By spreading the load balancing reduces the risk that applications experience performance issues. For example, you don't want to overload a server. Instead, let's say once it reaches its capacity, Google Cloud very smartly spins up another VM and redirects the rest of the traffic over there. It's cloud load balancing in this particular case is software defined. It's not like somebody, with a router in front of multiple servers just rerouting things. It's actually software enabled. So it's fully distributed, software defined, a managed service for all your traffic. You can use, for example, like HTTP traffic, HTTPS traffic. It provides cross-region load balancing. For example, your application sits behind a couple of regions. You can do cross-region load balancing, which includes automatic multi-region failover. Let's say one region goes down, all the other traffic gets redirected to the other region. It reacts quickly. Cloud load balancing reacts quickly to changes in users, traffic, network, backend health, and other related conditions. So you need to know about cloud load balancing. They talk about all the types of load balancing options. You need to know about that. DNS, domain name service. In this domain name service is what translates internet host names to addresses. A lot of people have heard about like DNS. Whenever you set up a website like in GoDaddy, you need to know your DNS. This is what DNS is. So DNS is what translates the internet host names, www.gdglawrence.com, to an IP address. And as you might imagine, Google has highly developed DNS infrastructure. It's also software based. You need to know about that. So cloud CDN, a lot of people don't know about CDN, Content Delivery Network. This is what Google has a global system of edge caches. Edge caching refers to the use of caching servers to store content closer to end users. Sometimes you're like, you got to clear your cache because I'm still getting the same thing. This is a CDN. It's because the information is served much closer to you, so that it speeds up much quicker, but with the caveat that you may have to reload it a couple of times to get the latest version. So your customers will experience low network latency. The origins of your content will experience a reduced load, and you can even save money. Instead of going to the server and fetch the contents from the server again, they get cached into a global network of content delivery network provided by Google, and is it is very efficient. So you need to know about CDN. They talk about VPN. So a lot of, let's say, your jobs, you need to use a virtual private network. Again, you need to understand cloud router, cloud, again, how to use the BGP, border gateway protocol. All those things come out in the exam. They talk about the multiple types of virtual private clouds, the multiple types of connections that you can establish with the Google Cloud. You need to know about that. But this is one of my favorite topics. We got to the storage options in the Google Cloud. How Google Cloud has storage options for ranging from structured data, unstructured data, transactional data, and relational data. So let's say when we're talking about structured data, we're talking about, for example, let's say, again, tables, rows and columns. When we're talking about unstructured, it could be like blob storage. When we talk about transactional, it's like, atomic operations, ensuring that a transaction is created. Relational data, like I mentioned, like RDBMS, tables, rows and columns, SQL, and whatnot. So a lot of things that you need to cover. We're gonna be, Angie, thank you again for your comment. We're gonna be providing the slides, and remember, all of this is available in this session's videos, in that module that I'm going over. All of that is available in that module. Cloud storage primary use is blob storage. Whenever you have binary large object storage, that's what blob stands for. Binary large object storage. Don't think about files and folders when you're talking about cloud storage. You got to think about object storage. That's what they call it. And a bucket is on one concept that you're going to hear a lot when we talk about cloud storage. So a bucket is kind of like how you group blob storage your objects together within a bucket. That's like the logical grouping of your storage, right? You can serve website content, storing data for archival and disaster. Cloud storage provides you all of that. They mentioned like the 4 types of cloud storage. Again, standard storage, nearline storage, cold line, and archive, and it all depends how much you access your data, how frequently you access your data. For example, standard storage is, they call it hot data. For every day you need to get data, that's standard storage. Nearline then is, for example, like infrequently accessed data, once a month or less. Then you get cold line, which is more infrequent, low cost, because again, you don't have to fetch it all the time. That's like once every 90 days. And then you, last but not least, you have archive. Archive storage is like, once a year, like that. You need to know about your storage options. You need to know that for the exam. Again, Cloud SQL, a lot of you, of course, you've heard of SQL, right? So Cloud SQL offers fully managed relational databases, including MySQL, Postgres, and SQL Server as a service. So again, they give you like a SaaS, fully managed version of these databases behind Cloud SQL. So you need to know about Cloud SQL. Cloud Spanner, which is a fully managed relational database, speaks SQL, but we're talking about like, in the petabytes, right? And really large, horizontally scalable, fully managed relational databases. It's huge. And actually, Cloud Spanner is what powers Google's 80 billion business. This is very heavily used like in the banking system, in the banking industry. One of my favorites, Firestore. Anybody's a fan of Firestore? NoSQL, cloud database for mobile, web, and server development. I love Firebase, and Firestore is a flexible, horizontally scalable database. You can store your data as documents, and then the documents are organized into collections. You can do like NoSQL queries. It speaks gRPC. It stores the data as protobufs, so it's very efficient. I love it because you can stand up. You don't need to provision any infrastructure to start using Firestore as a very reliable NoSQL database that gives you real-time capabilities, offline capabilities, and really rich way that you can store your data, like non-structured data. Bigtable is another one that you need to learn. It's also kind of like Firestore. It's NoSQL, but it's like for massive workloads at consistent low latency and high throughput. People use this for like IoT a lot, like Bigtable. You can use the APIs. We're going to talk a lot about that. All of that. What else? Here we speak about like all the cloud storage availables. Firestore, BigQuery, Deepa. That's me right there. Yeah, that's me. They talk about BigQuery. Remember, I didn't mention BigQuery within the cloud storage, which is okay, but it's because BigQuery, and thank you, Deepa, for bringing it up, is because it sits on the edge between data storage and data processing. And it's covered more in other courses in isolation. Why? Because BigQuery, you can use it for data analysis, interactive querying capabilities. It's not purely a data storage product. It's more like data warehousing, right? So that is pretty much what it's used for. Awesome. So we are almost at the top of the hour. This is what we envision you to be in the next 2 weeks. Remember, these are the official sessions that we're going to cover every 2 weeks. Session 1, we're covering, as you saw right there, we were doing the, well, this is the wrong slide, but I'm going to show you the correct one more time. So what you need to be, let me go back all the way here. Here it is. So you need to be in week 2 where it says, let me see, I can see my screen. Okay, so where it says developing applications with the Google Cloud Foundations. This is what we're going to be covering for week 2 in 2 weeks. In 2 weeks, we're going to be covering that. So for this week, we covered all the Google Cloud Fundamentals core infrastructure. Again, no rush, but it'd be great if you can catch up, and then you could be where we need to be in 2 weeks. So in 2 weeks, we're going to be covering developing applications with Google Cloud Foundations, which is an amazing topic. We already went through all the things as a review for the people who haven't done week 1, and a preview for the ones who haven't done it, and a review for those of you who completed it. Okay, so make sure to be on top of your game. Make sure to keep looking at the batch tracker. For week 2, we're going to be doing developing applications in the Google Cloud Foundations, and you can take a look at what it entails. I already completed that, but I'm going to just show you real quick. So these are all the things. This is the badge that you need to get for that. Make sure to sign up for the badge tracker so that we can add you. We need to know where you are. Well, we don't need to know where you are. We would love to know where you are in your journey. That way we can help you. So what else? Make sure to continue watching those videos and continue hammering all of that. Okay, great. So we're going to be covering all of that, but make sure to stay on top of your game. Before we wrap it up, again, we want to do the raffle. So that's what we want to do. We're going to do the raffle, and then we're going to take a picture. But just because, for those of you who are watching on YouTube right now, thank you so much. We're not wrapping up again for the folks live. We're just wrapping up the video because we don't include this part in the video. So I just wanted to say thank you so much. Make sure to stay tuned. Study your week 2, and make sure to go to the developing applications with Google Cloud Foundations. Thank you very much for watching this video, and see you on the next one. Thank you so much. See you on week 2. Okay, so now